Hey grade 9s, today we're going to talk about rotations and rotational symmetry. So when we rotate something, we turn it around. So as you can see, I'm turning this object right here and I'm rotating it clockwise. When you think about what clockwise is, just think about the hands on a clock. So here's um, here's the hands on a clock. And as long as we're going in this direction, this is considered to be clockwise. Okay? So, with that said, this is our original object here. I just took a piece of the original object there. If we were to rotate that object 90 degrees clockwise, it would become this right here. And as you can see, the 90 degrees clockwise rotation is the exact same as the original object. To rotate a total of 180 degrees, we're going to take the object that we rotated 90 and we're going to rotate another 90. So here's another 90. Now we've rotated 180 degrees. And again, it looks the exact same as it did at 90 and the original shape itself. Okay? If we take the 90 and we rotate it once more, well, we get to 270. And again, a 270 degree rotation is the same as a 180 and is the same as a 90 and is the same as the original object. All of that said works for this particular object. Other objects are going to have different orders of rotation or rotational symmetry, which we're going to talk about what those things mean and how they're related in just a little while. But this particular object looks the same at a 90, 180, 270, and if we do a full 360 degree rotation clockwise, it also is the same. So that object, it's 90, 180, 270, and 360 degree clockwise rotations are all the same, which is pretty cool. So now we're going to look at the nuts and bolts of it and try and decipher the mathematics that are here. So during one full rotation, the shape coincided with itself 4 times. Once, twice, 3 times, and 4 times. It didn't do anything more than that. It did it 4 times. Now, a shape has rotational symmetry when it coincides with itself after a rotation of less than 360 degrees. Every object, no matter what the object is, will have rotational symmetry at 360 degrees, but if it has rotational symmetry at any angle less than 360 degrees, then the shape has rotational symmetry. Okay? The number of times the shape coincides with itself over that 360 degree rotation is called the order of rotation. So obviously this shape coincided with itself 4 times, so therefore it has an order of rotation of 4. So that order of rotation of 4, that is not just pulled out of thin air. That's the number of times the shape coincides with itself over a 360 degree rotation. Okay? Okay. Now here, there's also a very important relationship for us, and that is this. I'll get my highlighter out, not my pen. There we go. To find the angle of rotational symmetry, it's always equal to 360 degrees divided by the order of rotation. So in this case, if the order of rotation is 4, then the angle of rotational symmetry is going to be 360 degrees divided by 4. So as we know, 360 degrees divided by 4 is equal to 90 degrees. So what that means is that shape has an angle of rotational symmetry of 90 degrees, and it has an order of rotation of 4. You can say either one of those things, and it describes the rotational symmetry that the shape has. You can say both of those things. If you say one will be able to find the other using this relationship right here. So this is very important. So when you go to do your practice questions, I want you to remember that relationship because it's going to help you enormously. So let's go ahead and do a couple examples here. Here it says which hexagons have rotational symmetry. State the order of rotation and the angle of rotational symmetry. Okay, so fair enough. Let's go. So I'm making a copy of that shape just so we can have it. And I'm also going to then, there we go. Okay. So now I want us to rotate it, and I want you to say how many times does it look identical to that over a 360-degree time period. Okay, so no, that's not the same. Boom, that's the same. And then we'll go 270 and 360. So it's the same twice at 180 and 360. So it has to be it's the same at least once before 360. And what we saw is that the order of rotation for this is 2. And the angle of rotational symmetry is just 360 divided by that 2, which gives us 180 degrees. Okay? Simple as that. Now you may say to me, well, how are we supposed to see that we can't just make a copy of something and rotate it on a screen? You're right, you can't. One of the things that I would do if I were you is I would put a sheet of paper over a question in the textbook or wherever the question might be. Maybe the question's, you're looking up the question on your phone, and so you put a piece of paper over whatever shape you're looking at. Trace the shape with a pencil, and then, if possible, cut out the shape with scissors. And then put a pencil or a pen or the end of a compass in the middle of the object so that you can rotate that object 360 degrees using your finger. And while you're rotating the object 360 degrees, you'll be able to see at which point during the rotation the shape coincides with itself and it looks the exact same as the original shape. And that'll help you because some people are very visual learners. Like they can just see things without having to do something like that. Personally, myself, I can't do that. So before I had a fancy screen to do something like this with, that's exactly what I would do is I'd take that piece of paper, I would trace that drawing, and then I'd go ahead and cut it up, and then I would rotate it. So I invite you to do the same if you think it would be helpful. Next question, we have this exact same thing. So what I'm going to do is I'm going to get a little copy of that object there. And going to drag it off over here. And I'm going to lock it. Now, we rotate it. That's 90, definitely not the same. Up to 180, not the same. Going ahead to 270, still not the same. Going all the way to 360 it's the same at 360. But it's only the same at 360. So if it's like everything's going to be the same at 360. So what we would say here is no rotational symmetry. There's no rotational symmetry for that object because when you rotate it, there's no chance for it to be itself until it's gone a full 360 degrees. Okay? All right. Moving on. So here we've got a couple examples here. Rotate pentagon ABCD 90 degrees clockwise about vertex E. Draw the rotation image. So how do you know what 190 is? Well, let's think about a circle here. Let's think about a circle. And if we think about our circle, when we look at going from here to here, that is 90 degrees. And so that's a good way of showing what 90 degrees is, but if you're still unsure, what I would do is I'd look at a protractor. And if you don't have a protractor handy, you could just even Google image search protractor, and it'll help show you what a 90-degree angle is. Okay? What a 90-degree angle is. A 90-degree angle is like the letter L. So again, because I do have the luxury of having technology to help me out here, I am going to make a copy of this. And once I have that copy, I'm going to go ahead and I'm going to rotate it 90 degrees. The key thing is it says 90 degrees clockwise. Okay? So clockwise goes in this direction. So if I go 90 degrees clockwise, about E, right? About E, that would go like that. And the thing that you have to understand is because it's about E, what that means is E is our anchor point. E doesn't change. Everything else changes around E. So if we can take a look at what this image here looks like, and basically take the information that we see here, and then what we're going to do is we're going to transcribe that over to our shape over here. Like one of the things that we see over here on the right is that A is 2 spots to the right and 1 spot up from E. So the same thing is going to be true here. Our new A is going to be right there. That's A prime. We can also see B is 2 spots up from E. So that's the new B prime. C is 2 spots to the left of B. C is 2 spots to the left of B. So that means that C is going to be, so it's from the new B. So that's just C prime right there. And therefore D prime is going to be 2 spots down from C prime. So it's going to be right there. And we're going to hopefully take a ruler to make these lines look really nice. I can't use a ruler on this, but I know that you could. So there you go. There's our new shape. It's going to look a lot better if you use a ruler. So please use a ruler when you're making these drawings. It makes them look a lot neater and it completes the drawing as well. Okay? So please use a ruler when you're doing these diagrams. Now our next example is we're going to rotate trapezoid MNPQ 120 degrees counterclockwise about vertex M. Draw the rotation image. Now instead of having just grid paper here, we have isometric paper here. And if you take a protractor and you measure 120 degrees, what you're going to find is that this line here and this line here form a 120-degree angle. So if we're rotating counterclockwise, that means we're going this way, then the protractor is going to be needed to get the 120 degrees, more than likely. I mean, the thing is that if we see something like this, for example, we know that's less than 90, that's 90, and that's more than 90. So we kind of have to use that kind of logic when we're dealing with our angles. If you know what 90 is, then an angle bigger than 90 will have a bigger separation between the arms of that form the angle. So with that said, our new n is going to be right here. That's our n prime. Then p is going to be like right here. Oh no, Actually, my new n, I need to move over. My apologies. My new n prime, then that's going to be my p prime. That's going to be q prime. And m is going to stay the same because that's our anchor point, our rotational center. So then we would use something straight to draw those lines in. And there we go. There's the new trapezoid after the 120-degree counterclockwise rotation about vertex M. Okay? Okay? All right. Now, using rectangle ABCD, we're going to do 3 separate rotations. We're going to do a 90 degrees clockwise, 180 degrees clockwise, and a 270 degrees clockwise rotation, all about vertex A, and then we're going to draw each of those images. So this is fairly straightforward, I'd say, because we can kind of see what it should look like. So if we're going to draw this for the 90-degree clockwise about vertex A, what it's going to look like is it's going to look like this. B will be above A now by 2. So there's our B prime, our C prime, and our D prime. So that's the 90-degree clockwise rotation about A. 180-degree clockwise rotation about A. Well, that's going to look like this. And A doesn't change. So the B is going to, this is going to be B double prime. This will be C double prime. And this will be D double prime. And then if we rotate it once more, look at this. And this right here is B triple prime. This right here is C triple prime. And this right here would be D triple prime. The block shape being the rotation of 270 degrees clockwise about the corner A on that rectangle. So, like I've mentioned, it would be helpful if you can't visualize this to even just cut out a little rectangle for this question. And because the anchor point is at A, which happens to be in the bottom right corner, then I would just put a pencil tip or a point or a whatever, something to hold that corner down. And then I would move the rest of the shape around, and you can see it rotate. And you can do the 90, you can do the 180, you can do the 270. And as soon as you visualize what those are, then you can go ahead and record what they are on a piece of grid paper like we have here. Okay? For homework, I'd like you to do pages 365 to 367, numbers 4 to 15, and again, try and make your drawings as neat as possible. You don't have to have a ruler to draw a straight line. Instead of using a ruler, you could go ahead and use the side of a book, the side of your phone, whatever's nice and straight. Okay? All right. Try some questions and make sure to ask for help if you need it.